All right, here we are with section 7, direct current and alternating current. Electric current may be DC or AC. That's where the band AC/DC gets their name from. If you happen to be a fan of really old rock. All right, so by DC we mean direct current, which refers to a flow of charge that will always flow in one direction. A battery produces a direct current in a circuit because the terminals of the battery always have the same sign of charge. So on a battery you always have that positive terminal with a nub and then the flat side, the negative terminal. With that, remember the electricity goes from the positive terminal all the way around to the negative terminal. So the electricity can only flow in exactly one direction. This is true for any circuit that has a battery, whether it's your car or your phone, it's all direct current. Electrons will always move through the current from the negative towards the positive terminal. I just told you that electricity is going to go from the positive to the terminal. This is kind of an argument for physics. When Benjamin Franklin first introduced the idea of electricity, he said it was always protons moving around through the circuit. That's not the case. And his idea was the protons are going to move away from the positively charged terminal and go all the way around because like charges repel and opposite charges attract. So the protons would move away from the positive terminal and be attracted to the negative terminal, and that's why they float. That's not really the case. In this statement here, that electrons move through the circuit from the negative terminal towards the positive terminal, that is true. However, in physics, we normally look at not the flow of electrons, but instead the flow of charges that are composed of a lot of electrons. Even if the current moves in unsteady pulses, as long as it moves only in one direction, it is DC. Any of your toys, all DC current. Alternating current, as the name implies, is the electric current that repeatedly reverses direction. So here we have current going this way, and then it changes direction, and now it's going this way, and then it's going this way, and then it changes direction. Electrons in the circuit move first in one direction and then in the opposite direction. They alternate back and forth at relatively fixed positions. So they're going back and forth like this in just small position. It's not traveling the whole length. This is accomplished by alternating the polarity of voltage at the generator. So imagine a battery that did not have the tiny little nubs and was flat on both sides. And if you hit a button, you'd get a nub on this side. And then if you hit the button again, the nub went away and popped up over on this side. And then hit the button again, the nub popped up over there. So the positive terminal is always changing. And that's what alternating current does. That's how it comes about. The electricity coming from your wall, that is alternating current. Voltage of alternating current in North America is normally 120 volts. In the early days of electricity, higher voltages burned out the filaments of electric light bulbs. Power plants in the U.S. prior to 1900 adopted 110 volts, or maybe 115 or 120 as standard. By the time electricity became popular in Europe, light bulbs were able to not burn out so fast at higher voltages. So if you go over to Europe on a trip or a cruise or whatever brings you over there, you have to get a plug adapter. Otherwise, when you go to charge your phone, it's not going to fit into the wall. Their plugs are different. They use 220 volts as their standard. We stayed with 110 volts because the installed base of the 110 volt equipment would have been too expensive to switch over. Although lamps in American homes operate on 110 to 120 volts, remember volts, that's the potential difference, that's the pushing of the current. It's the gaining of electricity, or gaining of energy for the charges as they move through the circuit. electric stoves and other appliances do operate on 220 and 240 volts. So if you unplug your dryer and look at that plug, it's a monster plug compared to the plug on your TV, which only has the 2 prongs. So you've got the 3 giant prongs for the 220 volts. One wire is 120 volts positive, one wire is 0 volts, that's that ground, and then one wire is negative 120 volts. In the AC, the positive and negative alternate at 60 hertz. A wire that is positive at one instant is negative 1/120th of a second later. So a hertz is the cycling back and forth per second. Most home appliances are connected between neutral wire and either of the 2 wires, producing 120 volts. When the plus 120 is connected to the minus 120, it produces a 240 volt difference, just right for electric stoves, air conditioners, clothes dryers, all of the big appliances. Popularity of AC arises from the fact that electrical energy in the form of AC can be transmitted great distances. So you can go really far away. Chances are you can't see the electrical generating station near you because it's coming from far away. Easy voltage setups result in lower heat losses in the wire. The primary use of electric current, whether it's DC or AC, is to transfer energy from one place to another. So, what are the 2 types of electric current? You should be able to answer that concept check now. There's also a story about Thomas Edison, who was a big proponent for alternating current, and Nikola Tesla, who was a big proponent for direct current. The 2 would go back and forth, saying their version of electricity was better, and it got to the point where Thomas Edison realized how much was at stake, so he tried proving to people that direct current was going to be very dangerous because it's going to go straight towards you and it's not going to be able to come back, so if it gets to you, it's going to kill you. To demonstrate this scary situation, he killed an elephant named Topsy. If you've seen Bob's Burgers, there's an episode about Topsy the elephant. That's based on true story. There's also a movie that's somewhat recent called The Current War that goes into this in a dramatic fashion. Interesting stuff. Check it out to find out more.